So, hello everyone, and welcome to this 14th session of Ask AuxEn Anything. And this is an online platform for civil and structural engineers where they can interact with us and ask their queries or doubts or difficulties that they may have related to the projects that they are doing or any concept related to RCC or steel design or general construction site issues. So this is the 14th such episode, and yeah, we are here today. So if you have any queries, you can ask us. Today we are quite late in sharing the link for this session, so I'm not sure how many of you have been able to put in your queries. So what we will do is that we already have a query. So let me just take it. And you can also now start typing your queries in the YouTube comments. So as I said that the link for today's session was shared quite late. So not many of you have been able to put their queries in the Google form. So you can just put your queries in the live comments and we'll just take it from there itself. Okay. Okay. So let us see. So what I'll do is I'll just share my screen and yes, so this is the first query that has been asked. This is asked by Mr. I'm just looking at his name. Arasan. Arasan from India. Okay, they have not mentioned their city. So Arasan from India, working professional. His question is: after analyzing model in STAD, we need to check deflection of beams for serviceability case. In STAD, deflection is shown for gross area of section without considering PT provided for beams. In this case, how to find deflection of beams with area of reinforcement provided. So very good. So he's trying to ask that generally, if you remember or if you know that in IS 456 there are certain modification factors, modification factors for beams depending on the PT and percentage of compression reinforcement. Okay. So depending on the percentage of steel, tension steel, and percentage of compression steel, there are certain modification factors. But you must understand that when you are using this modification factor approach, this is the first one of the approaches that is given in the code. And what this approach says that you find out L upon D ratio, okay, and then those L by D ratios are given. I think 26 for continuous beams, 20 for simply supported beam, something else for cantilever, and then you multiply it by, you're allowed to multiply it by a modification factor for tension reinforcement and modification factor for compression reinforcement, and then depending on L you calculate the, or you try to estimate the approx D, depth of the beam. This is the length of the beam. So here we use the modification factor approach. Now this is one of the, I would say this is the first approach given in the IS 456 for measuring the deflection. So if you, so here you are not actually measuring the deflection per se. You are not actually calculating the deflection. You are just maintaining your depth of beam in such a manner so that this ratio is satisfied. And if this ratio is satisfied, your code says that your deflection check will also be satisfied. Did you understand this? Okay. So this is the first approach where you are not able to actually calculate the deflection and you are trying to maintain the beam depth in such a manner that it satisfies this condition. And here you are allowed to use the modification factor for tension and compression reinforcement. Now, let's say if you have analyzed in STAT and you have already calculated the deflection from STAT itself. So here you just need to take the deflection from STAT and just ensure that it is less than L upon 350 or L upon 240, 250, whatever the ratio is given in the IS code. So here you don't need to use any modification factor. You just check the deflection from STAT and ensure that that deflection follows this condition. Is this clear? Yeah. So yeah. Now if you look at the ACI 318, I think it has the uh, what should I say? It has some additional factors that you can take for reinforcement also. But in this approach, as per IS 456, you just need to find out the deflection, analytical deflection, and just ensure it is less than this value given in 456. Okay. So I would say this is the second approach. And if you are using the software deflections, you are usually using the second approach. In the earlier times when we did not have software, when you were, it was difficult to analytically calculate the deflection of beam. Then we used to maintain the L upon D ratio in this manner so that deflection check is deemed to be satisfied. Okay, yeah, good. So I think this doubt is done. Now we go to a question that has been asked by engineer Harish from Udupi. He is a working professional and he is asking how to design the flared columns. Flared columns, we had discussed this in the last session itself. Just last week, we had discussed this in the same Ask AuxEn Anything series. In fact, I may have some images also made from last week's session. Yeah, so you see here flared columns. So I had explained this in the last session of the same series that that we conduct every weekend. So just go to the last episode and see over there. This issue has been explained well. In fact, you can see the images also from the last episode. Flared column. So just go to the last episode and check for this reply given to this query. Okay. Next question is how to check the double reinforced beam is under reinforced or over reinforced. See, if you are providing reinforcement for a cross section where the analysis moment has exceeded the mu limiting as per your cross section B, D, FCK and FY, depending on these four factors, you can calculate the mu limiting. Now, if your analysis moment exceeds this mu limiting, basically you are going to be in the doubly reinforced zone. And if it's doubly reinforced, that means it is a over reinforced section that we are providing. Okay. Yeah. If otherwise, if your mu is less than mu limiting, if the analysis moment for your beam cross section is less than the limiting mu limiting, then that means you are in the singly reinforced region. That means your beam is under reinforced. Okay. Yes. Okay. Then uh, so this was engineer Harish. Next question is from engineer Balaji. He's from Chennai and he is asking if I could just share my screen. Yeah, so Balaji from Chennai, working professional. Can you please explain? Okay, so I'll just copy this and maybe just take it there. Can you please explain how deflection check can be done in ETABS? If uh, in case we have section modifier values incorporated in beams, does that affect the deflection results? Yes, the answer is yes. Modifiers will obviously impact or affect the deflection result. Please tell some basics how we can incorporate precambers. Oh, precambers in analysis. I'm not sure how we can incorporate that in analysis or in the modeling itself. Usually, precamber is more of a thing that is considered during the construction stage. That means whatever is the deflection we are getting, usually due to dead loads, let's say. So usually due to dead loads, the deflection that we get, we generally provide a camber in our members, pre-camber. But in the analysis model, we don't usually do anything for the pre-camber that we are providing, and therefore we provide the pre-camber mainly for the dead load. Okay, so that means we don't have to wait for that deflection to come when it is loaded with live loads. As soon as you construct your uh, geometry, or as soon as you construct your structure, the dead load is there, so that pre-camber will be utilized in the deflection. So pre-camber usually we will provide it for the dead load, and that is why most of the times I have not seen anyone including that pre-camber in the analysis model as such. Next question was, will the section modifier value affect the deflection result? Yes. In fact, that is the idea of specifying modifiers, because we want to simulate the cracked behavior of your section, and that is why we provide modifiers. So when the section is cracked, the moment of inertia is reduced. That is what we want to simulate through these modifiers. So yes, modifiers will affect the deflection result. Okay, good, very good. So I think that was this question. Next question we have is from engineer Ashish Kumar. He is from Ranchi. He is a working professional, and he has also put his query in the YouTube live comment. So I'll just take it from here. What is he saying? I'm designing a 20-meter span truss shed. How should I connect the truss from I section column? Should I put should I directly put the truss bottom chord on I section, or should I do any different connection type? So yeah, you can put the bottom chord. Let's say this is my bottom chord, and I have made some top chord. These are my verticals, whatever diagonals. Let's say this is a back-to-back angle arrangement. So yes, you can directly put this. You can have a plate over here. This green plate is attached to the bottom chord through, and then you have provided stiffeners also, let's say. Then you can have another plate, and this plate is connected to the column below. So this green plate is connected to the bottom chord of truss. This green plate is connected to the bottom chord of the truss. This blue plate is connected to the column. And then you can connect these two plates together in order to achieve the desired connection. So yes, you can do this. You can connect the bottom chord directly to the I section column, but of course through some overall easier to uh, execute it on site. Okay. Okay. Mr. Vikash Kumar Pandey is asking, I have one doubt regarding crack width check. Which value of creep coefficient should be adopted for calculation of long-term mod? Oh yes, you had asked this question in the WhatsApp also, but I'm slightly confused. I will also need to check which creep coefficient should be adopted. I think 2.2 or so. 1 year, I think. I'm not sure. I will also have to check. So I'm unable to answer this question right now. I also need to check it. Mr. Ashish Kumar is asking, so the truss example, does it require any modification in stat? Yeah, so see, usually now what people like to do is that, let's say, suppose this is a sort of a pinned connection that you're aiming to achieve. So then what they do, that between this column and instead you have made it in terms of a line model. So at this location, maybe they will try to have a moment release instead. Suppose you are trying to have a slotted hole connection over here. So suppose you are trying to have a slotted hole connection over here, then what they do is that they will also release the translation and moment. So at the support, you can use the fix but arrangement and release those release those degrees of freedom from there, and then you can proceed. So usually in trust, people like to go for I mean, they try to go for a connection which behaves somewhat like a pin connection, or which does not resist movements. So they try to do it something like that, or then they will try to provide a slotted hole so that it behaves more or less like a roller connection. So usually instead you can use the fixed butt arrangement to do that. Okay. All right. What else? Mr. Arasan, he is asking how to design jack beams to support PEB rafter. Just a minute. So, Mr. Arasan, who had asked the first question of today's episode, he is asking how to design jack beams to support PEB rafter instead. I am modeling it as 3D structure such that jack beam rests on column, and what will be the releases for jack beam with column and jack beam with rafter. So usually, do I need to share an image, or people understand what is jack beam? Or should I share some image? Let me see if I have some image of jack beam. Uh, Jack beam. Wait a minute. I'll just open one image, and then we will discuss. Okay. So I'll open this Zamil Steel handbook, which has some good images. Just a minute. TV. I'm just trying to search for a jack beam arrangement. Okay. Hmm. This is it. No, but even this was not very good. Just a minute. I'm just looking for some jack beam arrangement. Hmm. This is good. So this image I have just taken a screenshot from the Zamil Steel handbook. So this is the jack beam. This blue item is the jack beam, and this black item is the jack beam. And basically, what does this mean is that suppose we didn't. So here, if you see, there was an internal column in this span. So in this span, there was this internal column or interior column. Again, in this span, you have got the internal column. Now, for some span, you wish to not have an internal column because you wanted a column-free space over here. So what you do is you provide this element. Now, this element will be column to column, and then on this element, this rafter will be supported. So this is called as a jack beam. I hope that is clear. So this green element, are just what is happening? Just a minute. I'm just not able to get out of this. Ah, it is something. Just hold on. Okay. So this green line is called as the jack beam. Nice question is how do somehow I'm not able to close this eraser. Just a minute. So jack beam is resting on column. What will be the releases for? Acha, how to design jack beam to support PB rafter? Yes, so how to design means you just have to design it like a normal element that you would do. So this jack beam that you see, somehow I'm facing some issue with the pointer, not able to use it. So this jack beam, just design it like a normal beam and which will be supported between these two columns. Now the releases or the junction type of junction that is preferred, usually it is the pin shear connection uh, that is usually preferred by designer over here. So they will like to go for a shear connection at these two locations. That is where the jack beam is supported on the column. The reason being because if you see closely, the jack beam is sort of getting connected to the minor axis of the column. So therefore, you don't want much of the movement to be generated about the minor axis. So usually this jack beam is connected as a shear connection with the column. Okay. Second question was what will be the and so about the design of jack beam, just design it like a normal PB element that you do, nothing special or nothing different over here. Then his second question was what will be the releases for jack beam with column and jack beam with rafter. Yeah, so now this rafter, if you see, this rafter is sort of symmetric over here, so it's not a very big deal because this rafter uh, is on either side of the jack beam. So here there is not much problem, but in some configurations of jack beam, you can actually have problems with the torsion that might come in the jack beam or torsion that might come at the ends. I'll show you another picture where the jack beam is connected at the ends. There your rafters may face problem of torsion. Like this. So here you see another image. Are you able to see this? Another image. So here what's happening? The jack beam is at the ends. Here the jack beam is at the. I'm not able to somehow get rid of this eraser. Huh. So here the jack beam is at the ends over here. This is my jack beam. Now this jack beam is, let's say, connected through a shear connection to the column. Now the problem here will be that the rafter may induce torsion in this jack beam, and that might be a problem for us. So here the connections, if you see again, a connection is being formed so that not much movement can be transferred, and only the axial downward forces or axial forces are transferred, not the moments over here. So this again will try to go for a shear like connection where the moments do not get transferred, because if moments get transferred to the jack beam, it will create torsion in the jack beam, which we don't want, or for which our jack beam cross section is not suitable enough. So we don't want torsion to be generated. That's why we will try to go for a shear connection. So I hope this answers. His next question is, also I'm modeling steel column with fixed support with pedestal. Kindly advise on the release at junction of steel column and pedestal top. No, so already you said you are providing steel column with fixed support. So if you are providing steel column with fixed support, that means the junction between steel column and pedestal top is fixed, which can resist movement. So accordingly, you will have to provide. Okay. Okay. So this was his question. What else do we have? Mr. Dinesh, he is joining us from India, and he is asking, in safe, while taking out the reinforcement, in safe while taking a reinforcement from finite element method for footing, combined footing, huge area of steel is shown at column, even at the face. Yeah. So what you can do is, suppose you have a case of isolated footing. See, when you look at the finite element results, you have to be cautious, because those finite elements outputs can show you local peaks. So what you can do, good way in isolated footings at least, can be that you make a strip width, and that strip width can be, I mean, if you look at the maximum of the books, you can have a strip width equal to, let's say, this B, when you are looking for this span bending, and then you can create a strip width which is having this dimension B2, let's say, when you are looking for this span bending. So when you will create these strips, then the software will do some internal averaging. Or you can do what? If you are not very happy with this, what you can do? You can go to IS456. There it says that whatever reinforcement you get, because if you look at the stress contours, it is mainly in this region that you get higher settlements in footings. So your code gives that width where you need to provide more reinforcement. So in fact, you can also make your design strip in safe equal to this dimension, and this dimension you can get from IS456. I'm forgetting the clause number, but it says that where you need to provide or where you need to concentrate the reinforcement. So the strip width also can be provided in the same manner. Okay. Yeah. So this you can do. His next question was, okay, so how to average stress. And when you make the strips, basically what the strip is going to do, it is going to do the internal averaging by using the Wood Armor's integration. Wood Armor's integration is the averaging technique that it uses. Okay. Then Code Raw is asking how can we design portal bracing in PEB? No, portal bracing is just rigidly connected. You can say beam element with column, and that rigidly connected beam element, we are calling it as our portal bracing. So just by using the standard principles of design, you can do the portal bracing also. Vikash Kumar Pandey is saying how to determine the depth of neutral axis for calculating crack width. Both the limit state method and the working stress method can be used. So see, if you follow the texts and follow the code, and because the crack width is a service check, so you will see that they are using, books are using, and code is also recommending you to use the working stress based approach for calculating the neutral axis. Okay. Yeah. Okay. Anything else? So today we were not able to share the link for questions before because I was tied up with some other things. So that's why the link for asking queries was shared quite late, just 2 minutes before the live session was to start. So if you have any further queries, you can just put them in the comment section. Whatever was in the Google form and the live comments, we have answered them. So if you have any further queries, you can ask, or else we close today's session. Okay, so I think there are no more queries. So that's it then. It was a short session. But yeah, we have answered the queries that were asked. Okay, so that's all we have for this weekend. We'll see you next time, next week. And thank you very much for joining. Bye bye.